Hello everyone watching this recording. This is a recording that will go along with the Unit 7 portfolio to help lead you through what it is you need to do to complete it and to answer the questions and get a good grade on it. So if you look in the file sharing pods, I have the GeoGebra file that you need to use for this, which is you're being seen right there, the triangle inequality GeoGebra file that I've made up ahead of time. The Unit 7 portfolio directions, the written directions, which I'll basically be following as I go through this. And also along with that, you also have the Unit 7 portfolio worksheet, which is what you would turn in along with the GeoGebra file that you are going to create whenever you submit your work for Unit 7. And the other work for Unit 7 that you'll be submitting is an alternate Unit 7 test, and there's only 2 lessons in it. So, and the 2 lessons that you're actually reviewing here are the main concepts that alternate test is going to test you on. So as you can see here, I have my screen split a little bit. I have the triangle inequality GeoGebra file open, as well as you can see the copy of the worksheet. And the first part of this wants you to explore this triangle here, okay? And what they want you to do with this, essentially, and what you're being directed to do with this, is that you're to create 3 different triangles, okay? Now, as a part of the conditions for that, and I just want to make sure we go through, I have everything listed here that I need to list. As you follow the directions for what's here, you are asked to make different types of triangles. Ideally, you want to be able to get a situation where you have at least one right triangle, one acute triangle, and one obtuse triangle, and the other 2 could be any type, but you want 3 different triangles. So you have the ability to change this main angle here by just like scrolling. Now you don't want any external angles like this. I mean, you want to keep it like this to be somewhere between 0, obviously not 0, and 180 degrees, which would be a straight line. So what you can actually maneuver with this is I can make a right triangle as well. I'll do the first one as a right triangle, and I can also change some of the outer aspects, like the sizes of these angles and these sides and whatnot. Okay, so now you're going to be presenting your own and make your own triangles of your own sizes, so don't use any of the measurements that I'm going to put here, but say this is the triangle I decided to create. So I'm just going to come to my information here. Let's try to see here. And I have it set up so that you could you don't have to, this isn't actually, just want to see here. Yeah, this is a table I made in Word itself, and not one that automatically becomes an Excel file, because this one is a little bit more down to earth. So I just want to put in the information I have here. So my side A here is 9.11. My B value is 10. Largest C and smallest C, I'm gonna hold off for a second. My chosen value of C is 90 degrees. You can put the degree mark in there if you want. Don't have to. A plus B, you should add these 2 together on a calculator, need be necessary. This isn't too hard with the numbers I happen to have here. It's going to be 19.11. The absolute value of A minus B is, if I subtract those, I'm going to have 0.89. And C currently right now is 13.53. Okay. Now, when it asks for largest C and smallest C, what I want you to do is take a look at this side over here, C, and move this angle about and see what makes it the biggest possible it could be, or the smallest possible it could be. So, if I go down to 0, it's hard to see here. I can see that C is 0.89, side C. as I move up, 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 it keeps getting bigger, 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 bigger yet, bigger, bigger. Get to 180, I get 19.11. I start moving more than that, and I have the external angles, which I really don't want. It starts going down again. So as it looks like here, when I get the largest value of C, I mean the smallest value of Z, I get whenever I have this at 0 degrees, and that's 0.89. And the largest value of C looked like it happened when I had it at 180. And I can see here that C is 19.11. You should see that there's some things repeated in this table, because we're going to be asked to come up with the formulas for the largest possible value of C and the smallest possible value of C. And as you see here, I mean, there's some correlation here between, you know, it looks like the largest value of C is the result of adding A and B, and the smallest value of C is the result of subtracting them and taking the absolute value. We don't want any negatives, because we can't have a negative side value. Let's move this a little bit here so I can see it better. So, you know, so let's see if that works with other possible triangles. So let's get this back to being a triangle again. Make some angle here. And again, I'm going to change the sides a bit. Move that a little bit. No, maybe don't want to move that there. See if I can move this out, if it lets me. Oh, it doesn't let me go any higher than 10, so I can move it in a bit. Move this in a bit, maybe. You know, I can zoom in if I want to a little bit. So say this is a triangle I want to create. Okay, so again, I'm going to put in the information down here. A is 5.92. B is 7.92. I'm going to have to verify that in a second. I'm going to be choosing a 64-degree angle with this. If I take A and B and add them together, I'm going to have 4, 8 carried to 1. Looks like 13.84. And when I do A minus B, it looks like in absolute value I'm going to have 2. And C is 7.52 in this situation here. Now again, for largest and smallest, I mean, again, as I go down to 0 degrees, C gets smaller and smaller until I reach 2. If I go any lower than that, or come back around this way, you know, C is always higher than that, and it gets back to here again, it's at 2 degrees. So, or at 2 units. So it looks as though the smallest possible value of C is going to be at 2 again. I should say that 2. And it looks like when it's at 180, again, the value keeps going up and up and up until I get to 180. And if I start going beyond 180, it starts decreasing. So it looks as though 13.83 is going to be the maximum. Now there may be some rounding issues here at times, you know, because again, one of the things we're looking to establish here is that the largest value of C that you could get, the largest value for the third side of a triangle, should be the sum of the other two sides. So, you know, here we have 13.83 and 13.84. 0.01 is not a major difference, okay? There may be some rounding issues here, but if you're close enough to what we're expecting to get, then you could assume it is happening. There's some rounding things that occur with GeoGebra at times, and sometimes you may not be able to get exactness. And so I did an acute triangle. Let's now do an obtuse triangle. And again, you still have the ability to move these things around, you know. Make sure that you're moving the angles accordingly and things like that. Make sure you don't lose track of which sides are which, or confuse which sides A, B, and C. And if you think that's happening, make sure that you always start back from the original file. Don't save to this file because, you know, one of the things you want to make sure that are happening is that, you know, everything's being maintained in the way I intended you to see it. So for number 3 here, I'm going to put my data in 5.92. No, actually, no, I want to change sizes. I'm supposed to change sizes between each one, so we'll say 4.7. And we'll say 4.78. So pretty close. So I'm choosing to have A, B, 4.7, B be 4.78. The largest value of C would be 9.48. No, sorry, take that back. I don't know that yet. My chosen value of angle C is 144 degrees. If I add those together, I'm going to get that 9.48. If I subtract them and take the absolute value, I get 0.08. And C is 9.02. And again, you know, I'm going to try to see what the largest value of C could be and what the smallest is. And again, I'm looking at 180 degrees for the biggest. Looks like it's now at 9.48, because if I go any lower than this, it goes down. If I go anything higher than 180 degrees, it goes back down again. So looks like 9.48 is the biggest value for C. And this is mimicking some laws that you learn about in Unit 7 here. And the smallest possible, again, happens when I'm at 0. And I can see that C is 0.08. So what you're going to be doing is manipulating this one around a bit so that you can make sure that you have, you know, this data to fill in. Now, I'm going to let you, I mean, you'll obviously do 2 more than this. I'm not, for the sake of time, I'm just not going to go and do the whole thing. So, this is when C was its largest value, was the figure a triangle. Well, if we go back here to 180 degrees, or what kind of situation we had? Let's go back a little bit. This is not a triangle. It's a straight line. So now this is designed for you to be, once you pull up here, you should be able to pull down a, you know, choosing the right, you should be able to choose from a drop-down menu. So no, it wasn't. And same thing with this. You know, when I was at the smallest value, which happened at 0, again, wasn't a triangle. And from the observations up there, it says, given that A and B are sides of a triangle, with the third side being C, C has to be less than. Now remember, when I was actually at 0 and 180, they weren't actually triangles anymore. Okay? So I still want to make sure I have a triangle when I'm making these statements. So if I have the third side of a triangle, you know, I always want to make sure that I'm, you know, smaller than my largest possible C value and bigger than my smallest possible C value. And the thing we're looking to establish here is, okay, well, my largest C value always seems to be the result of adding A and B, and my smallest C value always seems to be the result of subtracting A and B and then absolute valuing it. So I choose from the options here. I have that C is going to be less than A plus B, A squared plus B squared, the absolute value of A minus B, or A squared minus B squared, and of course we know it's A plus B from our table. And saying in here, C has to be more than the smallest value of C, which was the same thing as being calculated the absolute value of A minus B. And so those are the answers we want to put there. And it says here, the sum of 2 measures of any 2 sides of a triangle is, so if I take 2 sides of a triangle and add them up, how does that relate to the measure of the third side? Well, that sum has to be greater than the measure of the third side. And that's a rule that we learn about in this unit, so it shouldn't be a huge surprise to you. This one only has 2 parts to it, but there's a lot of stuff you have to do in this part here, so let's kind of go through this as well. Now again, I made this so that, even though it's a table, I made it because I wanted to have drop-down items here, and we're going to talk about this in a second. I want to make sure we have drop-down items there for you to access. We're going to be using this same GeoGebra file here. And it says, and what we want to do here is we want to determine an A and B value. We want to leave that constant. So I'm going to make it a triangle here right now. Okay. And what I'm looking to do here is once I establish what my A and B are. Okay. So say I choose them to be this. I'm going to say 6.08, and I'll make this a little bit bigger, 6.23. We make the numbers simple for you to do some subtraction if necessary. You know, so I'm going to keep these A and B values. As long as I don't mess with these points anymore and just move the angle measurement, you know, they're going to maintain the same thing. Okay. So I'm going to let A be 6, I'm going to let B be 6.23. Okay. Now, what I want to do for each one of these scenarios is, have several different measures for the angles. I mean, don't make 90 degrees used a whole lot. You can use it for one of the triangles in one of the scenarios, but here I'm going to let angle C be 78 degrees. I'm going to put in the data here. So side C was 7.7. Angle A was 49.68. Now just putting in the data here. Angle B was 52.32. If I change the angle to, say, 108 degrees for angle C, C was 9.9. Angle A was 35.22. And angle B was 36.78. And I'll do one more with this. And again, I can make it any size I want. I can make it even a smaller angle here. I'll make this like a 34 degree angle. And again, I'm going to move my sides around a little bit so I can see them a little bit better. And I might want to make sure I know what angles are where, so I know that this is the angle that goes with B. This is the angle that goes with A. So when C was 40 degrees, I had 4.19 for the side C. Angle A was 67.06 degrees, and angle B was 72.94 degrees. Now, I'm going to let you do the other two trials yourself, because what you should do is come up with new values for A and B. So you would change these at this point, and then pick three angles to do with that. I said you can make one a right triangle, just don't do it like all the time, okay? Because then you have some possible problems with that, all right? That don't really follow suit with this. So I'm going to look at the data that I have right now, and I'm actually going to blow up the screen here a little bit just to show this, because I have all the data I need from that part of the problem. And I think there was actually a part of this I skipped. Yeah, there's questions B and C that you still have to answer from problem number. No, it comes from problem 2. Sorry, I'm getting ahead of myself. So what I want to look here, I now have the 3 side measurements, A, B, and C. I have the 3 angle measurements in each scenario. What I want to do is look and see, okay, what's the smallest side, and what's the smallest angle, what's the largest side, and what's the largest angle. Pretty simple to answer when I have this data. So I look at this first point up here. I have 6, 6.23, and 7.7. So it seems like the smallest side is going to be side A. So I'm going to choose side A as the smallest side. The smallest angle was actually angle A. I'll take that back. Let's say, yeah. Because I had a 78 degree angle, a 49.68 degree, and a 52.32. So 49.68 is the smallest. The largest side was C at 7.7. And the largest angle was angle C at 78 degrees. I look at the second tier for the same two. Now I have 6.623 for B, 6 for A, and I have 9.9 for C. So again, in this situation here, A is still the smallest side. The smallest angle from 108, 35.22, and 36.78 is 35.22. So it's angle A again. The largest side, well, C is at 9.9, which is bigger than the other two, which are at 6 something, so it is C. And the largest angle was C at 108 degrees. And you should be noticing a kind of a pattern going on here, which goes with the rule that we talked about dealing with the geometry stuff. So last one for this trial, I let C be 40 degrees, so now I'm looking at this, and okay, now I have 3 sides, 6, 6.23, and 4.19. What's the smallest one? Well, now the smallest one is the 4.19, so now that's C. And what's the smallest angle? I have angle C at 40, angle A at 67.06, and B at 72.94. Looks like angle C is the smallest angle. For the largest side, 6.23 is bigger than the other two, so B is the side that's the largest. And the angle that's the largest, 72.94 degrees for angle B. Now, depending on what you choose, I mean, your answers may be a little bit different, but you should see a pattern here. You have to remember how these angles and sides work. Side A should always be opposite angle A. Side B should always be opposite angle B. Side C should always be opposite angle C. So, you know, and I've seen this pattern. When I have the smallest side, the smallest angle is opposite of it. And the largest side, you know, I have the largest angle opposite of it. And that's kind of the rule that we talked about. Because we're looking here in a triangle, the largest side is opposite the, I'm going to choose here, the largest angle. In a triangle, the smallest side is opposite the, well, smallest angle. That's always true. And these other things here, they want you to fill in based off of the information. You're given these sides. These are not drawn to scale by any stretch of the imagination. 4 feet, 6 feet, and 9 feet. You want to label the sides appropriately. So you have 30 degrees here, 126 degrees up here, and 21 degrees. So 21 degrees is the smallest angle. So the smallest side should be over here. And I have to look at which measurement's the smallest. And here I'd say, well, that's 4 feet. 126 is the largest angle. It should be opposite the largest side, and the largest label I have up there is 9 feet, so this should be 9 feet. And of course, 33 degrees and 6 feet go together because they're the only ones that are left. I mean, so I'll let you complete D on your own. It's the same kind of thing, except now you know the sides. You know, you can tell which one's the largest side and which one's the smallest side, and maybe put the angles in the appropriate places. So you want to put the 15 degrees. The degree mark's already been given to you, so make sure you put it in front of there so you can label it appropriately. You want to put the 15, the 65, and the 100 in the right places. Again, these are not drawn to scale, so don't look at this and say, well, this is obviously the smallest angle because it looks like smaller. Well, you can't go with that, okay? And this angle looks smaller than this one, or whatever it may be. You know, you want to use the measurements to make those conclusions. And that's, and problem number 3. I don't think we were doing that one. Let's see real quick. Oh yeah. Problem number 3 is going to have you create your own figure for this. Okay. And what we're looking to do is create, you know, a triangle with its median, with its what they call it, a mid-segment. Okay. Now I'm going to show you how to construct one like this according to the directions that you've been that are given for this. So I'm going to go back. I'm going to minimize this for a second and maximize this, because what I want to do is create a GeoGebra file for myself. So I'm just going to kind of say new here. I'm not going to save this because you might want to go back and retry it again if something seems to not be working in the manner I told you it should be working. So I'm not going to save this. I'm going to just start with a new file. I don't want any of this stuff here. I'm going to get rid of this axis. I don't want you to show this. Get that turned off. Okay, so I'm ready to start constructing what I need to construct here. So, and you want to make sure that you're constructing this pretty much the same way that I'm constructing this. I'm going to make these points bigger so you can have a look at it. So I want to make sure that you can see what's going on here. So I'm going to make the font size a bit bigger so it shows up bigger on your screen here, depending on what size you have there. So I'll make it 20. So I want to make sure I put these things in the same relative spots, because the measurements you're going to be making are going to be really dependent upon it. So, and the questions you're going to answer are going to be really based on what we're talking about here. So, so I want to make sure I make triangle ABC, you know, and I want it to be a non-equilateral triangle. So what I want to do is I want to make sure I create the triangle myself. So when I say here, you know, I don't want to create like a regular polygon. I want to create a polygon. So, you know, and I don't want it to be equilateral. So I'm just going to say, okay, I'm going to put A here, B here, C here, And I want to make sure I turn these labels on for this. Show the label. Depending on what your defaults are set at, this may or may not need to be done. Okay, so, all right. We want to construct the midpoints of BC and AC using the midpoint or center tool. So what I want to do is come over to here, and actually it's in this one here. Which one is it? Yeah, midpoint or center under the points menu here. And I want to choose midpoint or center. And the easiest way to do that is I just want to touch the line AB here, and I'm going to click on it, and it's going to give me the midpoint. And I'm going to do the same thing for BC and give it its midpoint. And again, I want to make sure these names show up, so I'm going to have it turn on its label if I can get to show the label so I can see it. Now if I construct it this way, no matter how I change A, B, and C, I'm going to have a situation where the midpoints will change accordingly. So if I change B, D and E are still going to be the midpoints. If I change where C goes, D and E are still going to be the midpoints of the segments we got. If you don't construct it right, the E will stay put, and D will stay put, and you won't necessarily have a midpoint anymore. So it's important to make sure that these always remain the midpoint, so construct it the way I just showed you. Go to your point area, choose midpoint and center, click on those two sides. Okay. Now we want to construct a segment at DE. So now I'm just going to construct a segment. I'm just going to click on D and E, and here's my segment. So I want to get measurements of the following angles. Okay. And I think that's what the problem is. I didn't follow my own directions. I could change that really quickly though. This is supposed to be sides. This is supposed to be C up here. So I'm supposed to find the midpoints of BC and AC, not AB and BC. So I'm going to change this to B. I'm going to rename this. For the time being, I'm going to say D. So I can't have two that are named B. I'm going to make this B. And if you make mistakes like that, you can always rename them to make sure it fits. The problem is this is going to be called D1 now, but hopefully when I change this back and call this C again, and I can now rename this back to being D again. So now that D is the midpoint of AC, E is the midpoint of BC. So we're good now. So this is what your final product should look like. Okay, D is the midpoint of AC, E is the midpoint of BC. So we want to take measures of these angles: angle A, angle B, angle CDE, and angle CED. So I want to measure those three. I want to measure those four angles here. So I'm going to measure the angle. And this is pretty much the same procedure that we used back in Unit 2, Lesson 1's first portfolio. So I'm going to measure the angle. Now, again, if I'm measuring the angle and it's coming out to be the exterior angle, stop measuring it, go the other way. Okay, and I'm going to do the same thing here. I think I have to probably go this direction. Nope. Should. I can do the same thing down here. And so measuring all these angles. Go back on that one. There we go. And again, I might want to move these around a bit so I can see them a little bit nicer and not overlapping anything. But I have these measurements now. Okay. And one of the things they're going to ask you to do is, you're going to save this, So you do a file, save as. I'm going to put it in my temp file area because I don't need it. And I'm just going to say, call it the triangle median or mid-segment dot ggb. And maybe to make it easy, I mean, just so you want to make sure you include this file when you're done using it, of course, with the work that you were doing on the worksheet. So we have this figure, and again, as I move things around here and here and so forth, you know, I can see what's going on there. They also want us to measure A, B, and DE, so I can measure the segments as well. And it's just easier for me. I'm just going to measure that segment here and measure this segment here and move it about. If I get it to move, there we go. Okay, I want to move labels. I didn't want the perimeter. Just trying to move this around. Sometimes things like this thing likes to have its own mind. So, and so I have those there. Side B is 12.32. This is the mid-segment length. And again, as I move these about, you know, or maybe move this about, things are going to change accordingly. Okay. Now you're asked you have to fill in the table based on these results. So let's fill in the table. Change this a little bit so we can see it all. And there we go. So like for instance, I say this is what I have here. So I'm going to say, okay, the measure of angle A is 43.82. The measurement of angle B is 55. The measurement of angle CDE is 43.82. The measurement of angle CED is 55. AB is 5.44. DE is 10.89. And I could do it again, you know. Change it about a little bit so that you get, like, you know, a couple of different viewpoints of it. You know, so here let's say AB 57.52 degrees. B is 42.67 degrees. CDE is 57.52 degrees. CED is 42.67 degrees. AB is 10.85. And DE is 5.42. Okay. And you're going to keep doing this because you're hoping to see some sort of patterns develop here, because there's relationships that we should see here. In all 5 trials, the measurement of angle A equaled what? And you have your choice here of CDE or CED. And if you don't have it equaling either of them, you're doing something wrong with your figure. And for this one here, and also depending on where you put D and E, if you put D between B and C and E between A and C, that might be a little bit different here. So one of these should definitely work. So for mine, angle A was congruent to CDE. Angle B was congruent to CED. Now let's look at these angles here, going back to Unit 4 stuff. These are corresponding angles. You know, they're in this, I mean, CB being a transversal, these two lines, they're in the same relative position at their intersections, you know. So, you know, when I look at these things here, and also when I look at the measurements, it says in all 5 trials, was it true that DE was equal to 1/2 of AB? Please keep in mind again that there's some rounding issues that sometimes happen with this. I mean, if I double 5.44, that's 10.88, so it's 0.01 off. And if I had these reversed here, yeah, this was the 10.89. I think I reversed that before, and this was the 5.44. And if I double to 5.42, I get about 10.84, which is again 0.01 off. So in general, I would say yes, they're about half of each other, with some rounding errors because of the way that GeoGebra has to round off things, because these are much more precise measurements. They're rounding to 2 decimal places here, but you know, these things are being measured to like I think up to 6 decimal places, and it's rounding off as a result. So you may not be getting exact amounts here because of just rounding issues. So But here it looks like, yeah, that's exactly what's happening. It's true. In all 5 trials, is it true that AB was parallel to DE? Well, since I have corresponding angles being congruent, I mean, I have 2 sets for each one of those situations. I have 2 transversals that are intersecting DE and AB, and the corresponding angles in each one of them are congruent. And so that would tell you from the corresponding angle postulates converse that they're parallel to each other. So yeah, that's true. And so the conclusion you want to draw, and this is a rule that we learned about in this unit. If a segment is drawn between the midpoints of 2 sides of a triangle, then that segment will be blank to the 3rd side of the triangle and have a measurement equal to the blank of the 3rd side of the triangle. So the 2 words are going to need to go here is parallel, and it's going to have a measurement that's equal to 1/2 of that, of the side of the 3rd triangle. And that's the end of what you need to conclude here. So, well, basically at this point, all you need to do is get, this triangle built, get your data filled in here, and these are the results you should basically get. And as long as you're constructing the triangle the same way I constructed to make mine look, you should be able to get the same results for all of these as well. So that's all I need. That's all I have at this time. If you have any questions with any of this, please sure to get in touch with me. Make sure that when you submit this portfolio, you're submitting the worksheet for the Unit 7 portfolio, as well as the GeoGebra file that you created. That should go in the Dropbox at the end of Unit 7, as well as the alternate Unit 7 test, which you should also be completing and putting in that Dropbox as well. So there should be 3 files in there when you submit it. The portfolio, the GeoGebra file that goes with that portfolio that you created, and the alternate Unit 7 test. That's all I have for now. I'll see you in live lesson or talk to you on the phone. But until then, have a good day, everybody.